Today we're diving deep into a question that has sparked countless debates in tech communities for years. Is Linux still the safest operating system in 2026? It's a topic that touches on security, user behavior, market evolution, emerging threats, and real-world usage. So buckle up, we're breaking the myths from the truths and exploring what security really means in the modern computing landscape. When we talk about the safest operating system, we need to first understand what we mean by safety. Are we talking about resistance to malware? Are we referring to architectural design? Are we critiquing ease of patching, transparency of code, or real-world exposure to threats? The answer isn't as simple as pointing to one scorecard or benchmark. Safety is a multifaceted concept, and today we'll measure Linux through multiple lenses. Let's start with the perception of Linux. For decades, Linux has been hailed as the fortress of the operating system world. It powers most of the Internet's servers, the majority of cloud infrastructure, and an incredible range of embedded systems. Many cybersecurity professionals will tell you that they trust Linux because its open-source nature enables rapid review, widespread collaboration, and accountability that closed-source systems lack. But does that inherently make it safer? To answer this, we need to deconstruct two key ideas: architecture and exposure. Architecture refers to the design of the system, how permissions, memory management, network stacks, and core components are built to defend against threats. Exposure refers to how widely a system is used and by whom. After all, a system can be secure by architecture, but if millions of inexperienced users misconfigure it, real-world safety plummets. Let's begin with Linux architecture. At its core, Linux was designed with a strict permission model. Normal users are separated from system-level resources. This means that even if malware or a rogue process runs at user level, it traditionally doesn't have the privileges to do system-wide damage. This principle of least privilege is a cornerstone of modern security, and Linux enforced it long before it was fashionable. On top of that, Linux distributions employ mechanisms such as mandatory access controls. Tools like SayLinux, AppArmor, and SMAC come to mind. These help define what each application is permitted to do, even if it runs with elevated privileges. Many desktop systems didn't make such controls default until much later, and some still don't, so when it comes to strong permission modeling, Linux remains ahead of many competitors. But architecture alone is not enough. We must also consider the open-source model itself. Because Linux code is publicly available, millions of developers, not just employees of one company, can audit, test, and challenge security assumptions. When a vulnerability is discovered, it often receives attention from multiple independent parties simultaneously. In theory, this should lead to faster identification and mitigation. In practice, it has advantages and disadvantages. The many-eyes theory is powerful, but not a guarantee. It depends on active participation, meaning people actually review the code. And while popular components like the Linux kernel see immense scrutiny, niche subsystems or device drivers may not. The sheer volume of code in a modern operating system makes it impossible for every line to be constantly audited. But overall, open source encourages transparency, shared responsibility, and collaborative remediation. Now let's pivot to malware and real-world threats. In 2026, threat actors are more sophisticated than ever. Ransomware, botnets, data exfiltration, and supply chain attacks dominate the cybercrime ecosystem. Windows historically has been the primary target of broad malware families. Why? Because it holds the lion's share of desktop market share, and attackers go where the most victims are. Linux on desktops has never held large market share against Windows or macOS. That naturally results in less malware written for it. But when Linux is deployed at massive scale in servers, cloud orchestration, routers, IoT devices, it becomes highly attractive to attackers. In fact, we've seen major Linux-targeted threats in recent years, including rootkits that hide in bootloaders, cryptomeaning malware, and exploits aimed at poorly configured remote services. In other words, Linux is not immune. It's safer in many regards, but it's not an impenetrable fortress. And as Linux usage grows beyond traditional niches, so too does the incentive for attackers to focus on it. Another factor to consider is patching and lifecycle management. Linux distributions tend to push security updates regularly. Popular distributions like Ubuntu, Fedora, Debian, Arch, OpenSUSE, And enterprise distributions like Red Hat Enterprise Linux and SUSE Linux Enterprise provide streamlined update infrastructure. In many cases, it's easier to stay up to date on Linux than on other systems because updates don't require license keys, forced reboots, or arbitrary waiting periods. However, updating software requires the user or administrator to act. The safest system can still be compromised if patches are ignored. In 2026, we are seeing more automated update frameworks, rollback protections, and transaction-safe packages. Yet the diversity of distributions and custom deployments mean that updates are not uniform across the ecosystem. Many Linux servers are managed by professionals who apply patches quickly. But countless IoT devices with embedded Linux languish with outdated kernels and libraries exposed to malware. So the safety of Linux in practice still depends on context and management. Let's compare Linux with other major operating systems. Windows today includes advanced security features like Windows Defender, HARDWARE-based isolation, virtualization-based security, and aggressive patch cycles. Microsoft invests heavily in threat intelligence and automated protections. Similarly, Apple's macOS integrates tightly controlled hardware, sandboxed applications, and curated app stores. It's a dramatically different security model from Linux, where users can install almost anything from many sources. Some argue that the curated App Store model is inherently safer because it constrains what can run on the system. Others argue that freedom and control ultimately empower users to secure systems better. In 2026, the debate continues. It's also worth noting that Linux itself has evolved significantly. Modern distributions incorporate hardened kernels, exploit mitigation techniques like address space layout randomization (ASLR), stack canaries, kernel lockdown features, and greater isolation between processes. In enterprise environments, Linux is often paired with containerization and micro-segmentation. Technologies like SELinux and namespace help isolate applications, reducing the blast radius of any compromise. But the cloud tells a more nuanced story. Linux dominates cloud infrastructure, but that same infrastructure has been the target of large-scale attacks, cryptomining hijacks, and supply chain interceptions. While not a condemnation of Linux, this demonstrates that no system is invulnerable. Security is fundamentally a process, not a product. Let's explore some common myths. Myth number 1. Linux doesn't get viruses. This is outdated and overly simplistic. Linux can and does get malware. The difference has been historically one of quantity, not immutability. Because Linux usage on desktops has been smaller, fewer widespread malware families have been written for it. But that doesn't mean it's impossible to infect. In 2026, as Linux adoption has grown, we've seen more Linux malware in the wild. The real defense lies in strong user practices, updated software, and good firewall hygiene. Myth number 2. Linux is only secure because bad actors ignore it. This idea suggests that Linux is safe purely because attackers have focused elsewhere. While market share affects attention, the design principles of Linux, permission separation, modular architecture, open review do materially contribute to its security posture. So while the myth contains a kernel of truth, it ignores the structural advantages Linux possesses. Myth number 3. Linux is too complex to secure. Many people assume that because Linux can be deeply customized, it must therefore be insecure. But in fact, this flexibility empowers administrators to implement layered defenses. A properly configured Linux system can enforce stronger access controls and tailored protections compared to more locked-down systems. The complexity is an asset when used by knowledgeable defenders, but it can be a liability in inexperienced hands. This brings us to user behavior, a critical and often overlooked part of safety. An operating system can be architecturally secure, but if users run with root privileges, download untrusted software, expose insecure services to the internet, or ignore updates, they dramatically increase risk. The human element is often the weakest link. Linux advocates often emphasize that command line usage, manual configuration, and deep control make users more security aware. There's some truth to that. Users who engage directly with system internals tend to be more cognizant of risks. But this also means that inexperienced users may misconfigure firewalls, expose SSH without proper keys, or run unverified scripts as root. The result? Higher vulnerability. The takeaway: tools are only as good as the people who wield them. Another truth is that Linux dominates specialized systems like containers, Kubernetes clusters, and edge devices. Security in these environments depends greatly on orchestration, automated policies, and isolation techniques. In many container environments, improper configuration can lead to privilege escalation or container escape. Tools like seccomp, groups, network policies, and runtime security platforms help mitigate threats, but they're not magical. They must be configured correctly and monitored. In the cloud, where Linux runs the vast majority of workloads, cloud providers layer additional protections such as virtual firewalls, identity and access management, hardware isolation, and continuous scanning. So when we ask, is Linux safe? It's important to expand the question. Safe relative to what environment? A self-hosted Linux home server managed by an enthusiast? An enterprise Kubernetes cluster running critical business applications? A fleet of IoT sensors deployed globally? Safety is relative to context. In many respects, Linux has matured extremely well in its security posture. The ecosystem now includes mature package assigning, reproducible builds, extensive cryptographic tooling, and community-wide vulnerability reporting channels. Projects like the Linux Kernel Self-Protection Project, KSPP, aim to systematically harden core subsystems. The result is that Linux today incorporates defenses that rival and often exceed what mainstream proprietary systems use in similar environments. Yet we must also recognize that threat actors evolve. Attackers are leveraging artificial intelligence to scale recon, automate exploitation, and refine phishing campaigns. They're experimenting with zero-day chains against widely deployed open-source components. And because open-source code is public, attackers can study it just as defenders can. The transparency that strengthens Linux can also give adversaries insights, though defenders generally have the advantage of collaboration and rapid patching. So where does that leave us in 2026? Is Linux still the safest operating system? The honest answer is, it depends on how you define safe. If by safe you mean less targeted by mass-market ransomware and consumer malware, then Linux often fares better than systems with bigger desktop footprints. If by safe you mean built on robust, transparent architecture with strong permission separation and powerful access controls, then Linux is indeed among the leaders. If by safe you mean a system that will protect an untrained user regardless of behavior, then no operating system, including Linux, can claim that title. The truth is that Linux's security strengths are real, measurable, and meaningful. Its weaknesses are also real, especially when misconfiguration and outdated deployments come into play. A well-configured Linux server managed by experienced administrators is hugely resilient. A mismanaged Linux device exposed to the internet with no updates and weak credentials is a target waiting to be exploited, just like any other system. In 2026, we are also seeing hybrid approaches. Some users choose secure Linux distributions that prioritize hardened defaults, sandboxing, and automated patching. Others integrate Linux with security platforms that provide endpoint detection, threat hunting, and proactive response. The ecosystem itself is dynamic. It's not a static battle between safe and unsafe. It's an ongoing journey of adaptation, learning, and improvement. So let's dispel the oversimplified myth that Linux is inherently invulnerable. It is not magic. It does not live in a vacuum, but nor is it fair to dismiss Linux as insecure or outdated. It represents some of the most advanced security engineering available, and when deployed properly, it can outperform many alternatives. As end users, organizations, and technologists, the responsibility lies with us to understand the real risks, apply best practices, and invest in security as an ongoing process. Safe systems don't happen by accident. They are crafted through design, maintained through vigilance, and improved through shared knowledge. In conclusion, Linux in 2026 remains one of the most secure operating systems when measured by architectural strength, transparency, and professional deployment. It is not immune to attack, and it is not automatically safe just because it's Linux. Its safety depends on context, configuration, maintenance, and user behavior. The myths that Linux is virus-free or impossible to exploit are just that, myths. But the core truth remains that Linux's design and community make it a powerful foundation upon which secure systems can be built. As threats evolve, so must our defenses. Linux will continue to adapt, grow, and incorporate new protections. Whether you're managing a personal home server or safeguarding critical enterprise infrastructure, Understanding how Linux secures itself and how you secure it will make all the difference. Thanks for watching, and remember, secure computing isn't about choosing the perfect system. It's about understanding the tools, the threats, and how to build defenses that work in the real world. Stay curious, stay vigilant, and keep learning.